Diese Konferenz wird nun aufgezeichnet.
So everybody who has still the video active will be also on the video. So if you fall asleep or somebody is joining you, everybody will see it in the world. No problem with that. Okay, let's talk a little bit about the basic ideas that we are talking about today. I want to introduce you a little bit about the basic functionality, what happens over the network, what happens in the network protocol, what happens in the client to server communication, what happens when you are talking to a Firebird server physically on the network, how can you perhaps choose the wrong data types for having not such a good performance in your application. What happens when the database server gets an insert, update, delete, select statement from you? What's the basic idea behind oldest active transaction, next transaction, and all this strange words that a lot of people are talking about, but not so many people understand about that, at least not the basics, how to use them properly. So I think it's a very good idea. We are starting with a Firebird 2.5 installed on my local machine, on a remote machine, and also a Firebird 3.0 server. And you will see on the first part what we are talking about, a very simple database. So a very simple database. I will create that database. This one is the Firebird 3 database, and it has at the moment no current data inside. We are creating a very simple table. Create table test ID big int not null primary key, and a txt for the column VARCHAR 80, for example. You would say later that the number of VARCHAR definitions in the database model could be a little bit a good decision to think about that first already, because later it could be a very bad decision to have a wrong data type chosen. So let's simply start, execute the statement, and we are committing that, and we are doing some test data. 1, 2, 3, 4, 5, 6, and Poland, Lazarus, Delphi, Firebird, Interbase, MS SQL. So some names simply to have some data inside our database. That's no big deal at the moment. Let's first start with the basic idea to have the same table to be copied to another database. That's a really simple task inside IBExpert, you know that. So I simply go to the table, I click right, and I say copy object, and I choose the other database registration, and I will say here simply copy everything, and that's it. So now we have also in the second database exactly the same table. That's really cool. So to show you what happens over the network, it is much easier when I'm not working with IBExpert, because IBExpert does so many things in the background. You will never understand what happens really in the network over the protocol and what happens from IBExpert, because IBExpert does so much things. We are using a very simple tool for that, ISQL. I really do not like that, but sometimes I show it for you. And what we are also doing, we are simply downloading a small application. You can also download this, IBExpert.com/TCP. And when you open IBExpert.com/TCP, you can download a zip file. And that's a very handy tool for us. I will put it here into the GT folder. It's a very simple kind of a sniffer for the network protocol. So what we have downloaded now is really simple. We extract that, and we simply have an executable file here, as you see, and we can start the executable. I will run that, and the executable has some really basic functionality. It is possible to bind an IP address, for example, 127.0.0.1, and we will, for example, bind the current address 3051 and map that to 3050. And we want to see the mapping activated, the logging should be activated, so I want to see what happens over the network protocol, and I want to have the data mode to be set automatically. That's a very simple way to do so, because in the next step I will also register already for the Firebird 2.5 already a second channel, 127.0.0.1, and now I take, for example, 3026 because I installed my Firebird 2.5 on the 3025, and the target of the redirect of the map port is the Firebird port, and I will also use the same functionality here and say everything fine. I want to say auto start and minimize to tray icon area. I want to say start mappings. It asked me for showing, saving the configuration. And on the logging page, I say, okay, simply store everything here, show everything here on the screen. And I can do now the following. I take the first database registration info, and I take the connection string from here, and I will simply now go to a command prompt. I go in my pre-installed Firebird installation FB30, and I start the ISQL with the connection string I just copied, minus user, this DBA, minus password, master key. And I change only the port from 3050, which would be the normal way, to 3051. So what happens now is the ISQL tool does not connect directly to the Firebird server itself. It connects to the TCP/IP network monitor, TCP/IBExpert it's called internally, and it will redirect everything to the Firebird server and send and receive all the data which come from your client application, send it to the server, and what comes back from the server to the client application. And when we are doing that, we will see the following. That happens if you are connecting to a database server. And this one here is now really simple. We have here some very basic data inside our network protocol, and based on the protocol that we are using and the configuration that we are using, it depends if it's encrypted or not. The default setting in Firebird 3 is that we are using encrypted connection. I will show you the difference. You can read here at the moment that we are working here, for example, with the first package which was sent from the client to the server. We are sending already the information. That one is a database connection that we want to have. We are using this DBA, legacy authentication, important to understand. We try to connect to the server using a legacy mode. And this one here is an encrypted sysdba password. And my current local username is administrator, and my current computer name is IBE162. And the server says, okay, hello, you're welcome, what do you want? And in the next step, it will give some additional application info, for example, isql.exe and so on. Everything is now sent to the server, and we will see some basic operations that are done by the client and send to the server, or directly send from the server to the client without asking for. If I send select asterisk from test, semicolon, not to be forgotten, we will see what happens over the network protocol. We will have a look at that part a little bit later. We will now do a quit, and we will now change some things at the Firebird server. So the Firebird server itself will now be stopped as a process. So the service will be stopped. We go to the Firebird config file, and regarding the legacy mode and everything else, I would recommend you to watch the older videos that we have already recorded. And I will now do first do a copy of the Firebird config file. Always good to have a copy, a working copy. And when I search here for legacy, for example, we will see here, for example, the several settings which were done or needed for the legacy authentication. Here, for example, we are allowing on Firebird 3 the legacy user manager, and when we are using the legacy user manager, that's an option. We have used that for last time when we were connecting, for example, from the Firebird 2.5 client to Firebird 3. Let's have a look at the other settings. Legacy authentication, Wirecrypt enabled. I will remove that. And I think that could be already everything that is at the moment needed. Legacy, I will just go through every line. Authentication server should also not be legacy. Authentication client should also not be legacy. Simply remove the or have the original installation from the setup, and you will have the data correctly set. So I think we should now have everything that we need. We restart the service. And now what happens, what the Firebird server does in default mode when you are connecting from a Firebird 3 client to Firebird 3 server. We are simply doing the same ISQL statement. And you see already in the first package that was sent over the network that it's a completely different stuff that was sent now. Part of the package is almost identical, but here's a very big string, whatever it is, a key code. So the client gets a key, encryption key for everything that is now sent to the server, and the server sends it back. So this one is a client package. The client generates a key, a private key, and this one sends a key for this private key. And now this connection is really secure. And when you have a look at all the later packages here, you will definitely be no longer able to understand what happens over the network. Let's prove that. We are doing here the first statement. I think we have to do the connect first because we were not allowed to connect to the statement because we have a different password. Master key with only the E or master K with a Y at the end is a different password. So now we think to have the second password. Sorry, I have to go back. That's also not correct. What is the problem at the moment? I will use this one is also not. I think we have to go back. I have to do the proper setup before, because in the authentication mode, I currently have the installation done with the password, so it should be no problem. We are going back and remove the new Firebird config file by the one that I had already and restart the service, because I just wanted to show you that any of the packages sent over the network in Firebird 3 in default configuration are completely encrypted. You are not able to read the data, so it's completely impossible to sniff over the network what happens over the network. And in Firebird 3, Firebird 2.5, it's completely impossible to have that functionality from the network protocol. If you're working on a network VPN or something like that, in that case, for sure, it's encrypted, but that part is not the part that was done by Firebird itself. From Firebird itself, it is now possible to have the encryption here activated. And as you can see here, we have now again the unencrypted data, because what happens when we are doing the select statement? Select star from, I will not do it with the star, I will do the txt from test, and you will see what would have been transmitted over the network if I would have said here clear and send it. So that's what happens physically when you are asking a Firebird server over the network. The client sends to the server, hello, I want to know something. Please give me the information about select txt from text. The server says, okay, you will get the following information back. You will get a column txt and some basic informations here in the background. And the client says, okay, perfect, give me all the next records, whatever they are. And then in this package, the server now sends to the client a lot of data. And as you can see here, for example, here you see the first name, here you see the second name, here you see the third name, and so on. So you see here some basic physical network protocol, which is really simple to understand, because it's also extremely readable. It's no problem to understand what happens over the network. And it's exactly the same that comes also with Firebird 2.5 already. So Firebird 2.5, if you have, for example, applications that need some more security also over the network, and you work with Firebird over the internet, it's no good idea to have an unencrypted protocol in Firebird 2.5. Always use a VPN tunnel for that, because anyone who is on the same channel that you are using, for example, on your router or on your switches or whatever, can read what you are sending over the network if he wants to. If it's encrypted, it's no longer so easy. What happens here, as you have seen, is we have simply one package where the 6 records are sent in, and the package is currently of a length of 216 bytes. Let's switch with some data type manipulations. At the moment, we are talking about a txt which was created in my database. As you can see here, we are now going not over the protocol, over the network tunnel, over the TCP IBExpert, so you will not see that configuration or that questions, that traffic over the network. When we have a look here at the second column txt is a VARCHAR 80. Let's have a look what happens when we are closing that and we are typecasting the second column on the fly. We are simply, for example, say type txt as VARCHAR 20, for example. And we say it should be the alias name for that newly created casted column txt, not with the E inside. And we start it again, and we have a look at the database server, and we see exactly the same data was sent over the network protocol in a package of 216 bytes. So having the short varchar or the longer varchar is not such a big difference. What is a big difference is when we make it much longer, but not from the network perspective. It's just a different here from the display perspective. As you can see here, now we have on the fly created a few thousand spaces. But the interesting part is with the varchar column, the spaces are not transmitted over the network. We are still in the same package size here in the network. One of the biggest problems is that a varchar 2000 or a varchar 32000 has still some disadvantages, despite of the fact that on the network it's a very fast implementation. However, the length that you are using for that, it's completely different from the storage perspective, but we will go to that a little bit later. Yeah, let's have a look at the next data type, and we simply move the data type from varchar 20 to CHAR 20. Which seems to be a good idea when we have, for example, a transmit over the network that is very short, and we know that we only have 20 characters over the network. Let's have a look what happens over the network protocol. Interestingly, with the CHAR 20, we are already at 260 bytes in the data package, which was sent from the server to the client. And when you have some hex code in mind, and you see here a lot of 20202020, these are spaces. And you see here a very proper line, Borland, Lazarus, Delphi, Firebird, and so on. It's a very proper line. Every column has always the same length. When you're using character columns over the network, the spaces are transmitted over the network. When I go back to the VARCHAR version, and even that I used it in the 2000 position, I see here now a different length between Borland and Lazarus, and then the shorter name Delphi and Firebird, and so on. You see here directly there are no spaces transmitted over the network. That's really important to know. VARCHAR has a different way of an implementation. VARCHAR always sends 2 length bytes in front of each string to allow the client already to understand when the next string will start. And we will see a little bit more about that later. So let's go back and make the really bad idea to go to our CHAR and send a CHAR 80 over the network. You see already 620 characters. And you see already, it looks already really bad here. There's a lot more traffic over the network, and a character column that will, for example, be used in a VARCHAR 8000, which is technically possible, will always result in a lot of network traffic that makes no sense at all. I will show you on the left, right, the scroll bar, and you will see here what is transmitted only because I used a CHAR 8000 for the typecasting. If you are using natively these data types on the network, on your database definition, you will have the same problem. If you are simply typecast on the fly, you can decide what you need to have. But what is a really interesting way to make the data as short as possible is, for example, to think about if we are working with very slow network connections. It could be an interesting idea to think about typecasting that to shorter varchars. If you know, for example, how long it is physically. It should not be longer than your physical implementation. TXT as VARCHAR 81 bracket is missing, so that's now again a working version of this secret statement. And what is interesting, let's have a look at, we are starting that statement again. We have now approximately 1, 2, 3, 4, 5, about 6 or 7 packages that were sent between client and server just for this short communication. Let's go back. Here was the last one, I think. Yeah, the 2 last ones. 2, 3, 4, 5, 6, 7. Exactly 7 pages were sent over the network. What is extremely important for the performance of Firebird applications over the network, and why a lot of people complain about that, when you are working over the network and you see something like that, and you see, for example, only this package, this first package, was sent from the client to the server, length 8 byte, which has almost nothing inside. It's just a kind of a request. Hello server, I want to send you something. And then comes the real information for that. This package, when this package is sent, you have already to calculate the latency time for executing that. And when you have, for example, a ping time to ping.yahoo.com, I think is a good example. Yahoo.com. They don't answer for a ping. Let's ping the good old Google. DNS does also not answer. I think it could be a problem that my configuration currently does not allow to get pings back. IBExpert.com does also not answer. Who cares? But you know what the ping time in general will allow you. And the problem is each of these packages will always need the ping time for the communication. So if you have an application that runs in a lot of individual packages over a network with a very slow ping time, it could be a very big problem for the application to work really fast. In a local network, you are typically working at around a ping time of less than 1 millisecond. In such a situation, it's typically not a problem to run always also bad designed applications. But when you try to run a fat client application over a network, connecting to a remote database server, and the remote database server might be somewhere in Australia also, it could be a very stupid idea in that moment, because in that time, this package will already need 300 or 400 milliseconds. The next package will need 300, 400 milliseconds. The next package will need 300, 400 milliseconds. And you will get a very slow reaction of your application. One of the ways to do your application is also important to know. When we are going here, for example, and we are working not with individual VARCHAR or CHAR columns, because CHAR or VARCHAR informations and also all other data types except blobs are transmitted in the same data package. Except blobs, I will directly show you that. Cast as blob sub type text, for example, and we send that over the network, we get exactly the same data with some overhead inside here ISQL. But the biggest problem is, have a look at the scroll bar here. I have not really counted that, but it's approximately, don't know, 20, 25, 30, 35, whatever amount of packages. Interestingly, we get here a information that this one is a package Borland and this one is a package Lazarus. So what we have here between two data records, blobs are always transmitted in their own network protocol page. You will see directly for any blob in that application, you will get your own data package over the network. And we have 1, 2, 3, 4 packages between 2 blob records, blob data. And what happens, let's have a look at this information there when we have, for example, 2 typecasts. And we say again, cast txt as blob. Could also be a subtype text again, it's no problem. Subtype text txt2. For example, we are now emulating a application that has 2 blob columns in the same table. What happens in that moment is extremely simple. We are getting the information, server's getting the SQL statement, and the results are sending ball end. Let's go back to the top. So sending ball end again. Sending Lazarus again, and so on. So you see already, if you are using blobs over the network, it's already a really bad idea over slow networks. It's not a general problem, but you have to think about how to use them properly. And one of the things I always recommend is really think about the number of blobs inside your main tables. The better construction from the database design perspective is mostly that you are concentrate on non-blob columns in your main table application, in your main table definitions, and you perhaps think about storing blobs somewhere else in your own table, because a blob is typically not the part that is shown automatically in any application, especially not the binary blobs like PDF files or so. We are doing our database design typically in a way that we have our PDF files in an own table, because when somebody scrolls through a line, through DB Grid or something like that, that is, for example, showing the data of customers or orders or emails or whatever, we let him scroll through the data, and when he stops somewhere more than 250 milliseconds or so, in that case we are getting the data from the blob table. We do not get the data with any of the scroll before navigate, on navigate, whatever events that you know perhaps from Delphi client application developer perspective. And when you are working, for example, with your own application, and you are starting your own application over the TCP IP expert, it could be that you have to stop here again the limit 2 very fast, because a lot of people cannot even start their application within the first 5,000 lines. It's often a very big problem to understand that. And when sometimes you want to see the rep lines also, let's see here, that is in our situation, this one does not have to do anything with that. Let's go here, for example. When you have, for example, here the rep lines, when you no more space is available, because long data is sent here in the data packages, it will be used for the full line, but we have very, very short data at the moment. To improve your application, simply try to run your application and use exactly the same configuration that we did. For example, one of the things that we can also do when we would like to optimize, for example, IBExpert, could be, I will go here in clear, I will modify my database registration info, and I will now also use the 3051 port. What happens if I now go over the network? you will see here a very big amount of SQL statements simply executed by IBExpert, simply because IBExpert was starting a connection without displaying anything. That was already done by IBExpert. And you can imagine, if you have a look at your own application, it could be a very interesting way when you, for example, go and clear and you do a specific function, whatever you are doing. For example, you open a simple table in our case. What happens over the network? And you will see also in your application a lot of statements where you have no idea what is this one for. This one is exactly the filling of the DB grid that here's, for example, for the tables needed, for the table columns needed. A lot of system data is connected from the IBExpert IDE to the database, and we need all these information to simply display the data with the column informations. And we still do not even have any of the records here transmitted over the network, because it will only start when we are going to the data page. But on the data page, we also get some additional informations and so on. A lot of these informations are created by components, and components often do a slightly good or bad job, depending on how you see that. If you want to have, for example, the component to check for you, is a column read-only or read-write, is a column nullable or not nullable, and so on, it has to use SQL statements to understand what behind that. The problem is often that you are not aware of that. And when you are open, for example, a specific table over a slow network, and you have some SQL statements that you have not initiated, you simply say, okay, select from whatever and open the data set. It could be a very big amount of background information that is sent just because you are using specific components. And this is a very good way to improve also the functionality of your application over slow networks. And slow networks sometimes simply means that slow networks are not really networks that are as slow as you think they could be. So no one has a database server in Australia when he works from USA or so. I think mostly will not, especially not over the network protocol. But sometimes you have to think about using perhaps some operations in a different way. We found on that way also some background information, some background SQL statements by applications. For example, for the German Army, we had a very interesting project where the German Army was buying some consulting days from us. And I was there as in German Air Force. It was a medical, whatever area of German Air Force, which doing the checks for the pilots. And they had an application written in Delphi using a Firebird server as a backend. And it was extremely slow to use that. And the problem was we were seeing over this protocol here inside, we were seeing that the application was doing a lot of stupid things, even when you are not even using that application. And the problem is there were 50 or 55 certified doctors for these checks. And they were sitting all over Germany. And they were connected using remote connections to a terminal server. And the terminal server was connecting to a local Firebird server. So the general problem was not really over the network related. But when we were using the network monitor for the protocol, we saw a lot of statements that nobody was capable in the Army team to explain why it was done. And we were simply searching the parts of the SQL statements inside their source code. And we found a very stupid implementation on a component which was a T transaction component. And the event was an on idle event. So what happened? when the transaction is idle, it does something on the network. After it was doing something on the network, it is again idle, so it does it again and again and again and again. And when you are working with one database connection from this application already, the Firebird server was almost already in 24/7 operating 100%. But if you're trying to work with 55 users on that application, it was almost impossible to use that. And we simply removed that on idle event. And immediately the software was really usable in that moment. And that was really strange because nobody knew why this on idle event was even done. And the things that they were doing in that event was perhaps based on the source code, was already done, added in the source code 10 years ago. But nobody had any comment inside that, what the purpose of that was. It was really funny to find that. And it was also a very nice team. German Air Force is also sometimes very different to other armies, I would say. They are not really army-like, especially not the German Air Force in that area. They are more or less cool guys. So, but what I wanted to show you, as I have already shown it to you, what happens when I cast this to blobs. When I cast this data to blobs, I get some additional information on top of the blobs, but I also get the individual blobs, each by package. So it's not a network, efficient way to transmit your data, but you can make it much more efficient than you might have think. Because when you, for example, want to send the data in the smallest possible way over the network to a client application, you can check out, for example, something like this. The list operator allows you to get the data in a kind of a CSV style, a limited format. And when I send that over the network, I get a blob as a result, unlimited size possible. But if we have a look at the real data that comes over the network, it looks a little bit more records than we had already over the other situation. But let's have a look at this package. We have now 104 bytes sent over the network. So sending the data, for example, over the network using a list operator with the limiter here, and the limiter can be sent or changed on the fly. You can also, for example, send a limiter like the hash or something like that. In that case, we have a data set limited by hashes over the network. So it also looks here in that way really easy. Or we can, for example, use a limiter like this one. For everybody of you who does not know how to create a carriage return line feed in SQL statements in ISQL on the fly, it's no problem to simply use a carriage return line feed inside your string. It is allowed inside almost any application, and it's really easy to have now a record sent over the internet, which is still very small. We still have only 104 bytes to be sent over the internet to have almost exactly the same data sent over the internet, over the network protocol, using that. So that's the most efficient way for this special way of data to use a network protocol. Always have in mind the definition of your database model, and if you are, for example, using CHAR columns, CHAR column is typically, from my perspective, something that you should use if you really have limited amount of data. For example, a number plate in some countries, for example, a number plate in UK is, I think, 7 or 8 characters or so. So if you're then using a CHAR 8, that's a good idea because you also have some spaces inside. But it could be a very stupid idea to have, for example, a CHAR 1000 for a specific key that is perhaps not even always stored in complete length. In that case, a CHAR is definitely no good idea. I always recommend to have at least at CHAR 10, think about, couldn't it be better a VARCHAR in that moment? It's always a mixed environment. When you see the next part of the session, you will also see some disadvantages of the VARCHARs, but that are not so big disadvantages rather than having a lot of spaces transmitted over the network, because mostly the network is one of the slowest parts of the data transmission that you have in big companies. Then, because even when you are working with SSDs on local machines with 1 GB per second reading and writing, or 2 GB per second reading and writing, it does not help you if you are working on a 1 gigabit network with 1,000 people and everybody tries to send millions of spaces over the network because you made some stupid decisions while you are creating the database. That's one of the things I just wanted to show you here from that part. This application is free for everybody who wants to use it in his own environment. You can download it from IBExpert.com/TCP. We simply allow anyone who knows that application to use it in any environment. That's a free technology that you can use for such an application. Yeah, outside your application debugging, you will also see some really strange situations when you're working with DB grids also, and in the Delphi environment when you're working with a DB grid and you see only, for example, 100 records or 50 records in the DB grid, you will see over the network protocol that already a lot more are already transmitted from the Firebird server to the client. And that's one of the things you also should have in mind. Firebird always tries to fill up the data packages if it makes sense from Firebird perspective. So if you have on a DB grid perhaps only 5 lines or so, it could be that the Firebird client protocol gets already first 100 or 150 lines of data. And for the next scrolling, page down operations inside your application, you will not even see that more data is transmitted. But at some situation when the cache is more or less not really empty, but should be refilled by the decision of the Firebird client, it will get the next number of records from the Firebird server. So it could sometimes be the case that it makes sense also from when you test your stored procedure programming or your client application programming. It's always a good idea also to run your statements over the network, not only over the network, but to check and run your statement with that button here, the 2 arrows, because this one is execute and fetch all. And when you want to see, for example, performance, what the performance makes with your application or with your statement, it could be a very good idea to have that running until the end, because in that case it could be that at the end there is a record which consumes a lot of triggers, stored procedures, lookup, select, subselect, whatever statements, and you will not even see that if you have only fetched the first whatever amount of records. So you will have to have that in mind. So that's a part for now from ISQL. Let's quit ISQL and let's do some more stuff with ISQL. Didn't I say something else? Okay, let's start an ISQL session. Let's do not start an ISQL session over the no longer active proxy, because we do not need that at the moment. We just want to have a direct connection to the Firebird server. Let's have a look. Select txt from test where ID equals 1. Okay, that's Borland. Let's go to another session. Select txt from test where ID equals 1. It's also Borland. Everybody would accept that. Let's think about it's perhaps a different value now. Update test set txt equals or 2020, whatever it is, where ID equals 1. Okay, let's have a look what we are seeing here. We still see Borland. Let's have a look why this happens. We have an open transaction. We did not commit the transaction. Okay, let's commit the transaction. Let's do the select again. We see BOR 2020. And you can guess whatever you will see here. It's very different guessings. I often have at trainings where I do that, different ideas. Some say that it's Borland, some say that it's BOR 2020. And in fact, it is Borland. Why does this happen? Let's start another session and do a txt from test where ID equals 1. We see BOR 2020. Doesn't he say it's Borland? He still says it's Borland. Okay, let's do some update on that. Update test set txt equals BOR 2021, where ID equals 1. Let's have a look here. Still Borland. Let's have a look here. BOR 2020. Let's do the commit here. And let's do the select. BOR 2021. BOR 2020. Borland. What's that? Versioning or multi-generational architecture. One of the really great inventions that are inside the Firebird ecosystem, also, but they were already introduced by Jim Starkey in, I think, 1983, he said, on the Firebird conference in Fulda. If you have known Jim on a conference or somewhere else, it's a very strange guy. I really like to listen to him because a discussion with Jim is more or less a one-way discussion. You get to know what you have to know, and you can ask some questions. That's okay. And if your questions are too stupid, he will stop to answer them and answer something else. It's sometimes really strange to talk to Jim, but he's really brilliant in his concepts and in his ideas. He's perhaps not so brilliant in communication, even that he's a smart guy. It's sometimes really hard to convince him to understand or believe something. But what is here the basic idea? Jim told us that he invented that idea while taking a shower. And there is a very nice old story about Jim when he was working on that idea with the blobs. He tried to convince his former employer, which was DEC. The database he was working on was RDB. One of the reasons because the system tables are always called RDB because some of the architecture that was already invented for RDB product was still used in the Interbase product, but the prior product before Interbase came up was named Groton Database. That's why Interbase databases were called GDB. And I think Ann Harrison told us on the Fiber conference also, they found out that from marketing perspective, it was not a good idea to call a product Groton database, only because the city of Groton was the city where Jim and Ann lived in that time. The very interesting part was because when they were answering on the phone Groton database, a lot of people were understanding rotten database, and rotten database is definitely not a good idea to have a marketing concept based on that. So they decided to call that product interface, and it was very long years before the internet and so on. So it's still, from my perspective, a good name. But since a few years, I think interface is no longer really a good product. That's one of the things that you always should have in mind. Firebird is definitely the much more advanced product compared to interface. Whatever they told you about their features. We have a lot of big customers who have really big problems with stability in the interface product. And one of the things that you always have in mind, one of the things why you're using a database is stability. If you store data inside the database, it should not forget that. And if you have questions to the database, it should answer that. And nothing else is the reason for using a database. Yeah, let's have a look at what happens technically inside. Does it still have BOR 2020 or does it already have something else? It's still BOR 2020. Who believes that? How does the Firebird server and also interface, for example, store that? When I go now here to the application and I go here, for example, and say I write here a completely different name, my last name, and I commit that and I write that down, the SQL statement is now showing me clamped. This one is showing BOR 2020, this one is showing Borland, and this one is showing BOR 21. This is not stored from a client caching or whatever you have in mind. And it's also not stored what is a technology that is used by several other databases in a kind of a transaction log, whatever technology inside the inside the database server. It's a more or less very easy way how it is handled technically. Let's go to the database statistics, and I think a lot of people of you heard about the database statistics, perhaps started that already and knew some of the numbers might be interesting, but not really know what is in reality interesting. Let's have a look at what we can see from inside the database statistics. We see a lot of numbers, and a lot of numbers simply means we have only one table. But we see here in this one table already a lot of information. Let's go to the tables view inside IBExpert and have a look at some more compressed information, because in the tables view it's easier to understand that. So the table test currently is on one page distributed, one page, 16K. That's really a small amount of data that is used by that table. Interestingly, it does not show you here in the number of bytes the bytes used for block pages. Block pages, for example, if you are using a specific table with several block columns, they are often using, based on the size of the blob, individual blob size column data, they are using so-called blob pages, and block pages are not counted here. So if you have, for example, a database of 100 gigabyte, it could be that you see here only data of around 20 gigabytes or so, because all the used blob pages where you store all the PDFs or images or whatever are not really visible in that column. And also the statistics value does not show it to you. There is a new feature in Firebird 3. One of these columns here are also showing you how many blob pages are used. I do not know at the moment where it is, but I think it's somewhere. The much more easier way would be simply click on blobs inside IBExpert, and it will show you the maximum amount of blobs, the minimum amount of blob column size, the total amount of blob size, and the average size. So it gives you a very good overview about the tables that might perhaps use much more space inside your database than you would expect. We had, for example, a few days ago, we had a very strange situation. A customer of us is working on an application where he was storing product data for restaurants, and the product data for restaurants also have some recipes. And if you, for example, you want to do sex on the beach or whatever, they have some technical description how to do that, but also a picture inside their application, how it should look at the end. And the problem was, we are doing the replication stuff for them. That's one of our biggest customers with replication over more than 200 restaurants all over Germany. And we are working on approximately, don't know, 2 or 3 million new records every night. And they restarted their business, I think, 1 or 2 weeks ago, because most of the restaurants are again allowed in Germany to operate in their business. They have still a lot of restrictions, but they are back in business after approximately 2.5 months of zero revenues in 200 restaurants. That's really, yeah, hard. But this company was able to handle that. What I wanted to talk about was that we received a blob data record with a picture. And in whatever way they were creating that picture, it was a JPEG picture. It was very strange because when we were looking at the data and we were storing the content of the blob was approximately 220 megabytes of size. And a single page, a single picture of 220 megabytes looked a little bit strange already, even when you're using the biggest Nokia, whatever, handy cam or something like that with 1 million megapixel or whatever. A single picture that has 200 megabytes is really rare. And when we looked at that picture, it looked even more strange because that picture was approximately a resolution of 800 by 600 pixel. So that was really no reason to have that amount of data stored inside the database or inside the blob. When we looked at the hex data in the blob, so if you have a blob here, for example, inside such a table, you can anytime open the blob column here, and you will also get the blob data directly in the hex editor. And when we looked at the blob data inside that column, we saw that after approximately 12K of data, there started a new JPEG. And after the next 12K, there started again a new JPEG. And we said, oh, that's strange. Why do you store so many pictures in one picture? It makes no sense because it's not a video, it's a single picture. That was the reason for that. And they had a really stupid component to create these kind of pictures. And it seems that some kind of blob stream was storing the data into a blob stream, but perhaps they forgot to initialize the blob stream, and they simply put it every blob stream of pictures again to the next picture, to the next picture, and so on. It was really horrible to see what they are storing in that database. And I was also in that moment a little bit angry about, because it's almost impossible to have a proper replication of a single record with more than 200 megabytes over really slow networks in 200 restaurants. And when we found that, I was directly deleting that picture and told the customer that we had to redesign this application, because that definitely makes no sense, because he cannot be it's not really a way to write your application if you write such a stupid amount of data for a single picture of 800 by 600 pixels. But what happens here? I still read clamped, and I can still read a lot of information here. What is that? That's really simple. In the database statistics, we see here in the tables, we see we have a total of 6 records. That's understandable because we know we have 6 records. And we have here the very interesting information. We have 3 record versions. 3 record versions. Okay, 1, 2, 3. That's interesting because at the moment when we have 3 record versions, Firebird does it in a very specific way. And we try to show it to you a little bit more in depth. One of the tools that is also built in IBExpert is Database Inside. And when we try to open now the database file from file system, inside Database Inside, it does the following. It simply opens the database file without any Firebird server. It can also be used for repairing your database. It's also one of the videos I think I made already. If I did not make it already, I can make it in the future. And let's have a look at the several content of the databases. We will see here, for example, that one is the pointer page for the record. And you see here, exactly, you will get some error messages here below, but it's not really a problem. You will see here, for example, some basic informations. We are talking about record number 1. When I click on record number 1, we see here the current name, what is currently written inside this record. And this one has a previous version, which was created by the transaction 251. This one here at the moment shows us an error message. That's only not really a problem, but it shows us the correct data for 2021. This one has a previous record version created by transaction number 246. And as you can see here, that one is a technical storage only of the difference between 2021 and 2020. The 0 was different before. So in a record version, Firebird always creates something which is called a back version. So it always has the current version inside the database, and the difference to the previous version is stored inside the record version to save some space. And it's really a very interesting way to do that. Also one of the architectures that Jim had in mind already almost 37 years ago, because it's one of the first technologies that Jim uses also then inside in times of Groton database. And this one was the original record version. And there we can see, for example, BOR land. BOR was the original part, but land was in that case a different to the prior version. And you see already, which is called a back version. So it's really interesting to see what's physically inside the database, just to have the possibilities what we are seeing here now. Because the current version in any new application that will show data from this table will only see the current version, because a new application will always have to connect to the database, getting himself a transaction ID. And the next one would be, for example, the transaction number 290 or 295 or whatever. And it will see the most recent transaction created version of the record and not the previous versions. The previous versions are still available for all the other applications that we are using here. And one of the things that we can have in mind, let's have a look at this application. There is an information that we could read. Current connection from RDB $database. Number 44. Remember that number. And we are going back to the database statistics page. And it was the completely wrong column that I showed you. I didn't want to show you the current connection, but we can also use that for later operation. Current transaction was the part that I wanted to show you first. That's a 2, 4, 3. 2, 4, 3. Oldest active transaction. Okay, what's the meaning of the oldest active transaction? That is the transaction, which is the first started transaction in my current database, which is not read-only. That's always important. Read-only transactions are handled different, but the writing transaction, it could be that this transaction was doing some writing operation. The oldest active transaction can, for example, even that I started that a few minutes ago. Let's have a look at the database monitoring and go to the attachments. And let's have a look at the attachments. The number 44, you remember the number 44. And it was started at 1850, so 10 minutes before 7. And we are currently seeing here also the overview of all transactions. And the oldest active transaction is in number 244. And we see here it was also directly started when the application was started. It must not be the same number, it's the same timestamp for when the application was started, but it's really often the case. And what happens technically now is extremely simple. As long as this application does not stop its transaction, the Firebird server will always have to have the information of all the record versions between the record version this one can see. You remember that was Borland. And all the changed record versions, and the changed record versions, as you was able to see here, are only stored in kind of different recalculatable differences to the previous versions. So the original record from the old transaction is no longer available. It's only a back version, so-called. And the back version needs to be calculated based on the versions between the current and the previous versions. It's a very complicated task to calculate the real versions, but the biggest problem is more or less that when we are closing that and closing, for example, this one here, and we are trying to do what you have in mind as a so-called garbage collection and so on, and we want to have the record versions to be removed. We see here one table with record versions and we want to have it removed. We can, for example, here do a commit. What happens when I do a commit? When I do a commit and I do the select again, what happens? I see the current record version. How does that work? We will have a look at that a little bit later on the next step. But it's much more interesting now that this record, this transaction that was started a few minutes ago, we can now, for example, do an exit. This one is still active. That's a medium record version, I would say. Not the oldest, but a medium record version. We simply say, okay, commit and exit. And we still have Borland here inside. When we go to the database statistics, we still see all three record versions. it's impossible for Firebird to drop any medium back versions between the oldest active record version that it has in the database and the current record version, because it needs all the several version data for calculating the original value. And one of the biggest problems that we currently have, as long as this application will not stop working, we can do the following. Let's do some testing. We are using a, no, we are not using that because it's too slow. We are doing an execute block as begin, and because it's much faster way to create, for example, a new record version, DCL ID big int ID equals 100,000 while ID larger than 1, do begin, and I first do a delete from test. And since I'm lazy, I'm just copying that, drag it, drop it from here, and do a insert into statement. And I want to have it, and here we have the ID column already, and we say here a constant txt combined with ID. So we are simply deleting any record of that table, and we insert 100,000 new records. Try to start that once again, and don't forget to ID equals ID plus 1. It's never a bad idea to have a unique primary key. Okay, we have now created 100,000 records. Some advertising. It's not really advertising. I get no money for that. Why does it take so long? ID -1. That's a very good idea. Yeah. Yeah. Sometimes we have to think about that. How to stop that stupid operation? It's extremely easy. Not there, but there. Because I do not want to have this transaction cancelled, but I also want to show you how such a operation can be cancelled from that perspective. When we have here, for example, now a current transaction list, and we see one of the transactions will run completely nuts here, we will see that is not a good idea. We say, okay, cancel that. And on the other hand, it's a very interesting idea. I do not want it to close that completely. I just wanted to close that part. And I think that should have already done that. Otherwise, I will simply close my other IBExpert on that way. It's also an option. This one is still running. Important. It still shows us Poland. Even that I just created a few million record versions in that database without any useful task. ID -1 would be a very much better idea to have that here. And let's start that again. 6 records were deleted. And you know, for example, from my talks already, that we are now already in a very strange situation. We have already a lot of data inside the database, And when we go to the database statistics value again, let's go to the tables again. And at the moment, it shows us 100,000 records with 9 record versions. That's perfectly fine, because one of the things that the first operation did was never really committed, so there were never really the data inside the database. But what I do now is I start this operation again. We have in mind 687 milliseconds, and we commit that. 844 milliseconds, we commit that. 900 milliseconds. 891 milliseconds. 1 second plus whatever. Let's have a look at the database statistics now. Let's first have a look at our ISQL application. Still shows us Borland. And when we go to the database statistics, you will see here now a very different perspective. At the moment, we have 600,000 records inside the database. 600,000. Is it really 600,000? Yes, it is. The problem is we see approximately 100,000, but all the other 500,000 were already deleted. The other one have a deleted record version. A deleted record version is a similar technology than we had in our database inside just seen. A deleted record version will now be a little bit more complicated because we have some more data inside our database. But we see here, for example, different information. For example, I think there's also one information here where you can see, for example, the basic technical structure, but it's really complicated to understand that. But all these record versions that were already stored inside the database that are already deleted, this one is the deleted record version. The original 6 records were already deleted, but technically they are still there. And the problem is, whatever you're trying to do to remove these record versions, using gfix or database validation to sweep the database. Sweep, what does sweep do? Sweep simply opens every table, every data page from the database, looks inside the data page, and if there are records that can be dropped because no other transaction can read them, they are dropped. But the problem is, it's always depending on the oldest active transaction. Let's have a look back at the database statistics. The oldest active transaction is still the 243. So the problem is still this application. No, this application. What happens now if I say a commit and I do my select again? It shows me it cannot see anything for whatever reasons. It should see something, but that's not really the problem. I drop that and I simply restart the database statistics. And in the database statistics now we are seeing that the oldest active transaction is now the 583. That's really helpful. And when I now reconnect to the database and I go to the database statistics and start it again, and I go back to the tables, we will see here now that we have 999,000 records, but 0 record version. I did not even need it to start the garbage collection process because it was started automatically. In a lot of cases, the Firebird server does a very good job to detect that the garbage collection could be a good idea. And the only thing that I really did was to use the select statement from the ISQL application. And in that case, it had to read a specific record from one of the pages, and these pages needed, on these pages were definitely some records which needed to have some garbage collection processing, and that was a really good reason for Firebird to understand what's happening inside the database to do the garbage collection in that moment. The most important thing that you always should have in mind is, because of my stupid SQL statement, I blow up the database to almost 1 gigabyte. It will not go any smaller anymore again. That's a very simple reason why it does not happen. Because anytime when the operation requires a new data page, it takes the data pages from the operating system. And one of the things that changed between older Firebird versions and new Firebird version is that it does not allocate only one page. I think Interbase still does that. If it needs one database page or one index page, it will use one index page from the operating system, and that can be resulting in a lot of fragmentation of the database file, and that's never a good idea. Let's have a look at the basic idea that was coming from the individual table. I will do some more things, but I will drop that table to make it easier for you to understand that. I hope at least you will make it easier for you to understand that. But we can still start also on Firebird 2.5. Technically, most of the things I showed you just are exactly the same inside Firebird 2.5, Firebird 3, Firebird 2, Firebird 1.5. Technically, almost exactly the same. So you have the same problem with the transactions. You have the same open transaction always result in blocking garbage collection and so on. But what I wanted to show you is also one of the very important things, what happens if you change some of the structures. Let's consider we have a new record column. For example, we have an info column, and it's a whatever we want, big integer, no additional informations. And we store, for example, we commit that to see the new column here. We store, for example, at the record Lazarus, we store a value here of 123. I commit that. And you see in the status line of IBExpert here, a very interesting value, 253 changes of table test left. What does it mean? It does not mean you have 253 record changes left. That's no problem. But metadata changes. Because what happened when I added the new column with the existing data? It's really simple, nothing. The existing data still remains in the database, and the new column will simply be part of the system table. And in the system table, in the RDB$ relations and RDB$ relation fields, we have the information, which are the columns, in which orders these columns are arranged, and so on. And what is even more interesting is when we have a look at the database inside again. I will close the database for that purpose. It's not really a good idea to work with a reading operation on an open database file. And one of the things you could also understand here from database inside is here, for example, also that the basic information about the oldest active transaction and the next transactions, for example, oldest active, oldest interesting, and so on. Oldest interesting, I will explain to you a little bit later. But next transaction ID, for example, that is always a part that's always in the first page of the database file. So anyone who is working with Firebird and you initiate a new transaction from a client perspective, the database server definitely have to write the so-called database header page, which is the number 0 in the sequence of pages, again, to rewrite the next transaction ID. Because in that moment, when you have taken a new transaction ID, it must be directly written down to the database file. And when you are working with the so recommended way of forced writes active, you will directly see this page always be written. And that's really interesting if you're using a tool like the process monitor from sysinternals.com. You see that a lot of writings are somewhere at the end or in the middle of the database file, but a lot of writings are in the first page of the database file. And here you see the reason why that happens. The oldest interesting transaction, oldest active transaction, and the next transaction are stored inside the database header file. That's why it's written really often to the drive, whatever kind of drive you have. And that's also one of the locations where, for example, you see the information where the forced write setting is set or the database SQL dialect is set. You can see here directly also the hex position where it is stored. The more interesting thing is now, let's have a look at the primary pointer page for this table. The primary pointer page always shows the data also from this data page, for example. And I can see which one is the one for my local table directly, because I always see that any other system table relation ID is lower than 128. And with 128, the first table comes up with data that you have created and metadata that you have created. So let's have a look at this application. We see here the transaction ID that was responsible for writing the data. And as you have seen also, if we delete the data, we also see a transaction ID and the delete flag. And that's one of the strange things a lot of people do not understand. When you are deleting data from a Firebird database, you need more space, because the existing data will remain in the database, because when your delete runs in a rollback, you have to have the original record versions. If you deleted the data, you create new record versions with the transaction ID that was responsible for that. And at the end of your operation, it will go to the transaction inventory page. And in the transaction inventory page, you see here, for example, transaction number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on. Any byte is always a representation of 4 different transactions. So 2-bit represent one transaction, and they are really in a sequence stored inside the transaction inventory page. And when you need, for example, when you see, for example, a record version inside your database that was created by a rollback transactions, you do not have to show that. Or if it's an active transaction, like all the transactions that I just created because of my stupid operation, in that moment when it's an active transaction, I cannot show it to other connections that are can only see committed transactions. So that's really also a very important part of the database file structure, the so-called transaction inventory page. Because when you have, for example, created a database within 1,000 different transactions, and in transaction number 500, for whatever reason, you made some deletes, and after you made the deletes, you roll back the deletes. It needs to know that the delete record versions are not really committed, so the delete was not really the case, so the previous record version is still the record version that needed to be displayed at that moment. And so it's one of the reasons why the full transaction sequence also needs to be stored on the database file, and it's always part of the database file. With standard default page size from IBExpert, for example, when you create a new database page, or you do a backup and restore of the database with 16K. In one transaction inventory page, you have an amount of approximately 64,000 transactions. So the first 64,000 transactions handled by your database operating system are stored in one database page. If there's no more free space, it will take the next and the next and the next. The really important thing from Firebird 2.5 is really simple. In database inside, when we go to the pointer page again, and we have a look at the transaction ID, it is a 32-bit integer. That is one of the reasons why a database, when the database reaches 2 GB or 2 billion at the next transaction point, the database will go in a read-only mode. And in that mode, you will have to do a backup and restore. The problem with the backup and restore in that moment is that when you're starting a backup, it will not let you start the backup because it has to start a new transaction for that. When it happens to you, when you are really working with the database that reaches here approximately 2 billion, and it will show you, for example, that your database is now in read-only mode, cannot start new transaction. You will have to use gfix for setting the database in read-only mode, then doing the backup and restore. And after the restore, you can set it again in read-write mode. That's a way how to handle that situation. Or simply go to Firebird 3. In Firebird 3, we have a value, I think it's 48-bit or something like that. It's not 64-bit because 64-bit is not really needed, but it's a much higher value. I think it's approximately 60,000 multiplied by 2 billion. That is the upper limit of the transaction. And that's really, I think, a value that cannot be reached so fast. The 2 billion in our restaurant project with our customer, one of the database servers reached the 2 billion transactions in approximately 7 to 8 months. That was one of the reasons why we were changing the main database servers in that project to Firebird 3 already. But what I wanted to show you also was in the database inside again. Here we see the transaction ID, which is a number which was responsible for storing that. And the interesting thing here is also the format ID. Part of the record, part of each record in the database is always the transaction ID. Firebird 2, 4 byte, Firebird 3, 6 byte, I think. And 1 byte additionally is for the so-called format ID. What for handle is the format ID? When you have a look here at the records, you see Lazarus 1, 2, 3. When you go to the first record, it is Borland, and it does not even have the third column. This one has the third column. This one has not the third column. When I go back to the table, you will directly see that everyone has the third column. But everyone who was not really stored with the third column does not have anything really defined in that third column. It has a null value. Or the Firebird server emulates a null value because it does not know what's inside there. There's nothing inside. The format ID has always a representation in RDB $ format. RDB $ format is a table for each relation inside your database. And here is, for example, the definition of RDB $ format 1, and this one is the definition of RDB $ format 2. When I go to RDB $ format 1 and I go in hex mode, that's really interesting what to read here. It's much easier to understand that when you go to the as format information. And you understand here, for example, what happens here technically. Type 19, length 8. 19 is a big integer. Scale 0, no decimals. 8-byte length. And offset, it starts at byte number 8. That's important to know. The first 7 bytes are used for transaction ID, format ID, and so on. And the next column now is type number 3. This is VARCHAR. Scale 0 makes no sense in that case. But here you see 82, but I defined the column as 80. That's the 2 length byte for VARCHARs that we have talked about already. And this one starts at byte number 16. When we go to the second format, let's go to the second format, to 2. We see here now, okay, now we have a different implementation. We have a big integer, we have a VARCHAR, 80, and another big integer. And what happens in the moment when somebody wants to see data from the database with a select statement, nothing else is done here to fill the grid, select stuff from test. In that case, the Firebird server technically itself will have a look at the original record versions, this one here, and he knows, okay, this one is stored by format number 1. In format number 1, in RDB dollar formats, I know the following columns. I know the first and the second column, and that's it. And the third column, I do not know, so I simply give it a null value. In the second record, I have the format number 2, so I have a different record implementation or a different record layout inside my database that I've stored inside my database previously. So that's also really interesting to know. And based on the problem that the RDB dollar format is always a 1 byte, a 8-bit number, this one that is shown here in the status bar, for whatever reason it's no longer shown here. When you see here, for example, the so many changes left on page, on table, whatever, to be changed. Don't know why it's not longer there. That's simply because the number of formats inside RDB dollar format, because if you're reaching for any of your tables, I think 255 formats, in that case, for the next metadata change on that table, you have to do a backup and restore, because in the backup and restore, all the old formats are no longer stored, and only the latest, the newest, most recent format is stored inside the backup, but also restored as format number 1. If you are seeing that value, when you are reaching, for example, 100, you will see it in yellow color. If you are reaching 50, you are seeing that in red color. And if you are reaching that number 0, perhaps you should look for another job or do some more often backup and restores in your life, and not always change your tables several times. I never had a situation where in a production environment we saw a value lower than 100, because in most cases, when you're doing a lot of changes in your database environment, it's always a good idea to have, for example, after a very big metadata change, to also do a backup and restore of the database. And within the backup and restore, you reset also all the RDB dollar formats. But if you have, for example, several tables which have 100 columns and you have dropped 99 columns of them, you will still have the same problem, that the 99 columns will still remain physically also in the database. You will also see the data inside the data pages, in database inside. You would see the original data here. So, for example, if I would now here, for example, drop the table, the column TXT, I will still see here Lazarus, I will still see here Delphi, and so on. even that I cannot see it any longer in my DB grid. It will not be removed or dropped automatically. You're responsible on your own to do so or not to do so. So that is also one of the physical effects of that. What is even more important is to understand what happens when we are doing that part again. Let's do the DDL here. I will do it in Firebird 3 again, just because we have it. And I will do the delete from test, will insert into test, and so on. And ID -1 in this time. That's a good idea, I think. And let's do it. Create 100,000 records approximately, and commit that. And while we were talking about long VARCHAR columns over the network protocol are not really a big problem. That's only one part of the truth. Let's have a look at if we are creating the similar table with a slightly different implementation. For example, we simply say test is now called test2. And we say this one is not 80, it's 32,000. I've seen some databases created by customers which are really big, using big data types, because they always think that has no real big disadvantage. In fact, they have real big disadvantages. You will see that in a few seconds, because it will do what we are doing now. Insert into test2, select from test. That's running fast, should be no problem. Commit that. That's fine. Select from test where ID equals 1, 2, 3, 4, 5. Runs extremely fast. Take it from test2. Almost same speed. Nothing to talk about. But let's have a look at the physical storage of that. We have exactly the same data in both tables. So we do not have any difference between the data in both tables, but let's have a look at the database statistics. What's the big difference at the moment? It shows us test and test2. It shows us that test takes, at the moment, for example, for the 100,000 records, 384 pages and 3,456 pages for the test2. Even if we have physically exactly the same records inside the database. And the basic idea for that is really simple. If we would have, I do not have a text editor on that, but you could have, for example, a look later with a database inside that table. We see here, for example, that we have a total number of records is completely identical, but with the test table, we have approximately 22 bytes per record. And this one, just because of the VARCHAR 32,000, we have approximately 522 bytes. Unpacked length, that's really the length physically that is needed for the physical memory operation that you will see in the next statement, that it also has a very big implementation, very big influence inside your operations. Unpacked length of this record is 32,000 bytes and 32 bytes, and this one is 112 bytes. And the compression is really good. It sounds good, but the compression is only the factor between the physical amount of bytes that are really needed and the unpacked length. Where is the unpacked length important? Let's have a look at the length for example, select first 10 ID txt from test, order by txt descending. Extremely fast, not really a problem. Let's try it with test 2. Some advertising. And waiting time has ended. Took around 11 seconds to answer this really easy question. And it had to read from disk to cache approximately 3,000 pages. And that's not all of the stuff. The biggest problem at the moment would be if we have, for example, a look at the database server itself. And we go to the details, we go to the Firebird server, Firebird. We are using the Firebird instance, and we select the columns, read bytes, write bytes, and say OK. And we, for example, disconnect to see that properly again. We restart the service. Restarting the service just by killing it. That's the fastest way. And if nobody's active on your database, that's okay. Don't do it in production environments. And let's have a look what happens when we are doing that on the first table. We have a reading of approximately 10 megabytes, writing of approximately 500K. That's not really a big problem. Disconnect that again, crash Firebird once again, and open the database again. A lot of the operations are already done while opening the database. But when we are doing that now on test 2, I will open that in parallel. What happens then? Two gigabytes reading, 7 gigabytes writing, and so on. So just for getting this information that was taking approximately 10 megabytes with the VARCHAR 80, took around 4 gigabytes, 4.7 gigabytes, and 11 gigabytes, 15 gigabytes approximately, just because we used a very stupid definition for this table. What's the reason behind that? In a select statement that does not use an index, you typically see a sort natural in your statement. And a sort natural simply puts the data that needs to be sorted in unpacked length into your sort file. And unpacked length into your sort file simply means it does not put 500 bytes for the physical representation inside the database page into your sort file. It puts for every of the 100,000 records 32K in that sort file. And you will see only because of this already that a very long VARCHAR column is, in a lot of cases, a very stupid idea. And when start a very long VARCHAR column, hard to say. A VARCHAR 200 can be already too long if you only need 10 characters. A VARCHAR 1000 could be definitely okay if you need to store some data that is in general using, for example, 900 bytes or so. So it's not so easy to say it's always bad or always good. The most important thing to understand is be a little bit careful about your database model, be a little bit careful about the blob VARCHAR and that design itself. Understand, for example, that the basics that you are setting inside your database model are really important. And sometimes it's much more easier than you think how to change your existing model. I think it could be one of the next sessions where we are talking about basic possibilities to improve the existing database model, but be on a specific level compatible to your existing database model, because a lot of people have the similar problem, and I think it's also a good task to understand for anybody. And I think we have some solutions for that. And if you need some personal training, also using GoToMeeting or some, I think in July, most of the airports, at least in Europe, will be reactivated again. Mid of June, most of the airports are already offering flights. I think my home airport here is already doing some flights, but when you see the airport in, for example, Frankfurt in 1 year ago and today, it's really horrible to see that. It looks really like a small island airport at the moment, but that's a different thing. But one of the good things in our business is if you need some training, we can sit wherever you are and wherever I am, and we can also organize such a training. And for the US market, just contact Christian on that. He's also contact at IBExpert.com available, and he will get some possible offers for you. If you have any more questions, Christian is now also online on the video.
Yeah.
Where's your beer? That's no beer. Yeah, let's some questions. Kevin, thank you. Dustin is already gone, I think. And if you have some more questions, just contact Christian, contact at IBExpert.com, support at IBExpert.com, goes on my desk, one of the first locations. I try to put questions to all the emails I get over the day. In most cases, I will manage that. Sometimes it's impossible, but that's the way how business works. If there are no more current questions, yeah, stay healthy. Thanks to everyone. See you, I think, next week. And let's have a look what happens, with this fucking virus and so on. Our family is back again. Congratulations. Is it Julian?
That's true.
Julian, congratulations.
Thank you.
Okay.
Was birthday over the weekend.
Yeah.
Okay, bye-bye and see you. And the video will be online back again in, I think, 1 hour, at least tomorrow afternoon it will be online. Bye-bye.
Perfect. Thank you, Olga.
Bye.